Hello everyone, in this video we are going to discuss the fifth problem which came in ISI BMath BStat 2022. This was the this was the easiest problem, so that's why I'm posting it later because no one had any query about this question, because I think almost everyone has done this question. The first one was also easy, but the fifth one I feel that it's the easiest one. So what it says is that for any positive integer n, let I be 1, 2, and if in denote the number of divisors of n of the form 3k plus I. So you know that numbers are either of the form 3k, 3k plus 1 or 3k plus 2. So 3k plus 2 numbers, it's better to view them as 3k minus 1 so that we get to calculate the powers easily. We'll come to that. So define any positive integer n, fn equals f1 n minus f2 n. So that means the number of divisors of the form 3k plus 1 minus the number of divisors of the form 3k plus 2. Okay, so find the value of f 5 to the power 22. They should have given some nice number, like I don't know why so easy, 5 to the power 22, but let's discuss it still. So okay, so this number 5 to the power 2022, yes. Now what are how the divisors of this number looks like, and also including 1 and n. So we have to include 1 and n if they are also of the form 3k plus 1 or minus 1. Now any divisor of this form looks like what? So there is only one prime factor. So any divisor d will look like of the form some 5 to the power alpha, where alpha ranges from 0 to 2022, right? So alpha will be having 2023 choices. So that's the total number of divisors of this number. Now let's figure out the 3k plus 1 or 3k minus 1 part. So first of all, 5 is congruent to what? Minus 1. So better to write minus 1, as I just told you, because it will help you, because the divisors are of 5 to the power something. So to calculate the powers, it would be better if you take minus 1 modulo 3, and so 5 to the power any even number 2k would be congruent to 1 modulo 3, and 5 to the power 2k plus 1 would be congruent to minus 1 modulo 3. As simple as that. Okay, and so these are of the form, these are the divisors of the form 3k plus 1, and these are the divisors of the form 3k plus 2. Okay, so now we just have to calculate how many alphas are there which are even starting from 0 and till 2022, and how many alphas are there which are odd. So basically the rest of them will be odd. So let's calculate the number of divisors of the form 3k plus 1. So that means the number of alphas which are even, that is 2023 plus 1 divided by 2, which is equals to 1012, and so this goes for this, which is f of 1n, and f of 2n is equal to 2023 minus 1 divided by 2, or you can just subtract 1012 from 2023, and that is 1011. And so when you subtract these two, that is f1n minus f2n, which is 1012 minus 1011, which is equal to 1. Okay, and that's the answer for the first part. For the second part, what we have to do is we have to figure out f of 21 to the power 2022. So this was also easy. 21 to the power 2022. So this is basically 3 times 3 to the power 2022 times 7 to the power 2022. Now any divisor of this number will look like of the form 3 to the power alpha and 7 to the power beta, where alpha ranges from 0 to 2022 and beta ranges from same 0 to 2022. And now you see that if alpha is any divisor you are taking where alpha is not equals to 0, it's greater than 0, then the divisor will be divisible by 3. So that means in our situation we should take alpha to be equals to 0 and then go for all the betas. That means if alpha is 0, then all those divisors basically becomes 7 to the power beta, where beta is running from 0 to 2022. Now 7 is congruent to 1 modulo 3, and so any power of 7 is also congruent to 1 to the power k, and so 1 modulo 3, and so all the divisors which are not divisible by 3 of 21 to the power 2022 are all of the form 7 to the power k, and they are of the form 3k plus 1. So here all such, not all divisors, all such divisors are of the form 3k plus 1. Okay, and thus we have how many such betas? 2023, and so the answer is 2023. Okay, and that's for this problem. It was very easy problem, and that's it for this video. Thanks for watching. See you in the next one.